All right, welcome back. Here we are going to learn now about evaluating functions. Now that we kind of have an idea of what functions look like, we're going to start talking about evaluating functions. And we're going to first talk about equations. And in our next video, after you practice evaluating with equations, we'll talk about graphs. Okay, but right now we're talking about equations. Okay, and we're actually just going to get right into some examples and what this looks like. Okay, so let's say we have three functions. Now remember, functions are like machines. So here I have three functions. I have three machines. This first machine is called f. And if I put a number into f, it takes that number and it multiplies it by 3 and it subtracts 2, right? So that's my f machine, my f function. My g function takes a number, it multiplies it by -5 and adds 1. Right? So this is my g function. And my k function takes a number and squares it, multiplies it by itself. Okay? So when I say something like this, evaluate, now we're evaluating functions. That means we're finding what the value is. So I'm going to evaluate f of 7. Okay, so this is my first example, right? And I'm going to use, for all my examples, I'm going to use these same three functions, these same three machines. And so first I'm going to evaluate f of 7. So we're going to figure out what that means. Okay, and you heard what I said. I said this, here's how you say this. You say f of 7. That's just how it's like how it's said. It's like a weird little language, right? Math is just like a weird language. So we say f of 7, and that means what value do I get when I take 7 and I plug it into this f machine? And so this is what it looks like. I'm going to say, okay, there's sort of two steps here. First is I'm going to say, okay, well, what letter's here? Oh, F. Okay, so I'm going to use this, right? And it's almost like I have three machines on my shelf. I'm going to go and get this machine. Okay, so I'm just going to copy my machine down just so I don't make a mistake. So I'm going to copy my F machine, right? Now, if this had been a G, I would have copied G. If it had been a K, I would have copied K. But so I went and I got my F machine off the shelf, and now what am I going to do? I'm going to take that machine and I'm going to put a 7 in it. So everywhere I see the X, I'm going to plug in a 7 instead. See, there was an X here. This said 3 times X. I changed it. Now it says 3 times 7. Okay, what does that equal? 3 times 7 equals 21. Bring down -2. This equals 19. Okay, so f of 7 equals 19. And notice I was like a little lazy here and I didn't write this f of 7. You can write it there. Or if you just want to kind of skip it till you get to the bottom. But your answer should look like this, right? It should be f of 7 equals 19. Should be, right? The answer is 19, but good for it to be written like this. Let's evaluate k of -5. Let's do this. I want you to get used to these words, right? I'm going to now evaluate k of -5. Okay, so this tells me I'm going to get the k machine, and my k machine takes a number and squares it. So now I'm going to take my k of -5, and I'm going to square -5. Now, watch what I'm doing. I'm putting the -5 in parentheses. Why? Well, because if I write it like this, that's unclear. Then I don't know if this is 5 squared with a negative attached, which would be -25, or if it means -5 squared, which is different because that's -5 times -5, right? Which is +25. And so what this means, when I say square x, well, in this case, x is -5. That means I'm squaring -5. So -5 times -5. Negative times negative is positive. 5 times 5 is 25. So k of -5 is +25. Okay, because I took the k machine, which was x squared, and I plugged in -5, and I got +25. Okay, so that's it. You're just plugging in and doing it. Now, there's a way that it gets just a tiny bit more complicated here. Okay, and I'm still using my same machines. And so now I'm going to evaluate g of f of 3. Okay, what does this mean? Okay, well, this means what I'm going to do is I want to plug into the g function. I want to plug in this number, right? Because look, it's always like the name of the function and then what I want to plug in. So in this case, the name of the function was f. I want to plug in 7. Here, the name of the function is g, and I want to plug in f of 3. Okay, well, just like order of operations, I need to do inside the parentheses first, right? In order for me to plug in f of 3, I need to know what f of 3 is. So I'm going to start on the inside. I'm going to start on the inside, just like order of operations. I'm going to start with my inside set of parentheses. So I'm going to first find f of 3. So what is f of 3? So let me go get my f function. Here it is. It's 3x minus 2. And I'm going to plug in 3. And notice I skipped a step, right? I didn't write it this time because we're just getting a little bit used to it. So f of 3 is 3. So it's f of 3 is 3x minus 2. So it's 3 times 3 minus 2. So that is 9 minus 2, which is 7. And I should write it right below, right? But I'm running out of space on my page. So now I got f of 3. F of 3 is 7. In fact, let me make this clearer and not do that. F of 3 is 7. So now I want g of whatever f of 3 is. So now what I want is g of 7. So look, I figured out the inside, and now I'm going to take that number, and I'm going to plug it into my outside function. So g of 7, so now let me go get my g machine. It's negative 5 times x plus 1. So negative 5 times, in this case it's 7, plus 1. So negative 5 times 7 is negative 34 plus 1. Okay, negative 34 plus 1, this is like I have 34 holes in my boat and I brought along one patch. Well, that's good. That one patch, now I have one less hole in my boat. Negative 33. Okay, and then what you can do is at the end, right, this is g of 7, but really what it is the whole process was g of f of 3. Okay, so you can kind of bring that all back at the end, because that's what we really evaluated, right? We did both of those steps. Let's do one more of those. Let's evaluate f of k of 2. Okay, so I'm going to do the inside first. So I'm going to start with k of 2. Now what does k of 2 equal? So k is x squared, so that's going to be 2 squared. So that equals 4. Now, so k of 2 equals 4. So I'm taking this k of 2 and I'm replacing it with a 4, right? So now what I want is f of 4. And so the f function was 3 times x minus 2. So I'm going to do 3 times 4 minus 2. And I get 10. And here I'm going to bring back my whole problem. F of k of 2 equals 10. Okay? It's going to be your turn right now. So you're going to go ahead and set up, and I'm going to have you set up your practice problems right here during this video, because it's just going to make your life a little bit easier. Okay, so go ahead and write practice. Okay, so we're in question 8 right now. So when you get to question 9, 10, 11, right, the next few questions, you're going to be using these functions. So you're going to copy them down right now, and you'll see them in each problem, but this will just make your life a little easier to have it set up across the top, just the same way I had for my examples. So here my machines are M, R, and another F. F is like a really common one we use. Okay, so then you're going to set up, and I'm just going to have you go ahead and copy right now. You could even do these problems if you wanted, and then go and plug in the answers. And here we get into where you have two functions. These are called composite functions when you have two. Give you a little bit more space for those, right? Question 13. And you'll be able to just go into the questions and see these questions as well. Oops. But kind of nice to just have the page all set up, and then you can just kind of get on a roll with it a little bit. but here is where you can show all your work. Okay, and there you go. So that's all set up for you to do questions 9 through 14. Okay, you're going to use those same 3 functions for all 6 of those questions.